Stalingrad, winter 1942. Soviet troops crouch in frozen trenches as German artillery pounds the city into rubble. Behind them, a supply convoy crawls forward through snow and mud. But these are not Soviet trucks. They are Studebaker US6s, stamped with Cyrillic markings and driven by Red Army soldiers, American-made vehicles delivering ammunition and food to the front lines of the Eastern Front. The Soviet Union entered World War II with a massive industrial base built around railways and tracked vehicles. Stalin had invested heavily in the Trans-Siberian Railway and built thousands of kilometers of new rail lines across the western USSR during the 1930s. The Red Army relied on trains to move men and equipment across the vast distances of the Soviet Union. But modern warfare in 1941 exposed a critical weakness in this strategy. Railways were fixed targets. German bombers destroyed rail yards, bridges, and locomotive depots with devastating precision. Once the tracks were cut, Soviet supplies stopped moving. The problem was not just strategic vulnerability, it was operational paralysis. Soviet forces needed flexible logistics that could respond to rapidly changing front lines. They needed vehicles that could drive off-road, navigate bombed-out cities, and deliver supplies to forward positions where no railway existed. The Red Army had trucks in 1941, but not nearly enough. Soviet truck production before the war had focused on the Gaz AA, a light utility vehicle based on the Ford Model AA from 1929. The ZIS-5 was heavier, designed for cargo hauling, but Soviet factories produced fewer than 200,000 of these trucks between 1933 and 1941. When Germany invaded on June 22, 1941, the Red Army had approximately 273,000 trucks in total across all military districts. This sounds substantial until compared to the scale of the Eastern Front, which stretched over 2,900 kilometers from the Baltic Sea to the Black Sea. Within 6 months of the German invasion, Soviet truck losses were catastrophic. The Wehrmacht captured or destroyed thousands of vehicles during the rapid advance toward Moscow. Soviet factories evacuated eastward ahead of German forces, relocating entire production facilities to the Urals and Siberia. Truck production collapsed during this chaotic retreat. By December 1941, the Soviet Union was losing trucks faster than it could build them. The mathematics of logistics were unforgiving. Every division required constant resupply of ammunition, fuel, food, and medical supplies. Without trucks, these supplies could not reach the front. Without supplies, divisions could not fight. Washington, D.C., October 1941. President Franklin Roosevelt signed the Lend-lease Act into law on March 11, 1941, authorizing the United States to provide military equipment to Allied nations fighting the Axis powers. When Germany invaded the Soviet Union 3 months later, Roosevelt extended Lend-lease to include the USSR. The first American shipments arrived in the Soviet Union through the Persian Corridor, a supply route running from the Persian Gulf through Iran to the Soviet border. By late 1941, American trucks began arriving in Soviet ports on the Arctic Ocean and the Pacific coast. The numbers were staggering. Between 1941 and 1945, the United States delivered approximately 427,000 trucks to the Soviet Union under Lend-lease. This figure represented more trucks than the entire Soviet automotive industry had produced in the previous decade. The most common model was the Studebaker US6, a 2.5-ton 6x6 truck designed specifically for rough terrain and heavy loads. Studebaker Corporation in South Bend, Indiana, manufactured approximately 200,000 of these trucks for Lend-lease delivery. The US6 featured a 6-cylinder Hercules JXD engine producing 87 horsepower, a 5-speed transmission, and all-wheel drive. The chassis was built to handle loads up to 2,500 kilograms on paved roads and 1,800 kilograms off-road. Other American trucks followed the same route. The Dodge WC Series, GMC CCKW, and Willys MB Jeeps arrived by the thousands. Soviet drivers encountered vehicles that operated differently than anything they had experienced. American trucks started reliably in cold weather. The electrical systems worked consistently. The engines ran for thousands of kilometers without major repairs. Soviet mechanics noted that American trucks required less frequent maintenance than Soviet-built vehicles. When repairs were necessary, the parts fit precisely. Bolts threaded smoothly, gaskets sealed properly. The tolerances were tight. Marshal Georgy Zhukov, who commanded Soviet forces during the decisive battles at Moscow, Stalingrad, and Berlin, later reflected on the impact of American trucks. In his memoirs published in 1969, Zhukov wrote that the Red Army could not have maintained its operational mobility without American vehicles. The Studebaker trucks, in particular, became essential for moving artillery, ammunition, and troops across the vast distances of the Eastern Front. Soviet soldiers nicknamed the Studebaker US6s the Studer, a term of respect reserved for equipment that actually worked when needed. The cultural impact went beyond logistics. Soviet drivers experienced a different philosophy of vehicle design. American trucks had cushioned seats, effective heaters, and cabs designed for driver comfort during long-distance hauls. The Studebaker US6 featured a spacious cab with good visibility and controls positioned for ease of operation. Soviet trucks, by comparison, treated driver comfort as an afterthought. The GAZ-AA had a hard bench seat and minimal weather protection. The ZIS-5 was marginally better, but still prioritized cargo capacity over operator experience. This difference reflected broader design philosophies. American truck manufacturers competed in a civilian market where drivers had choices. Companies like Studebaker, Ford, and GMC built trucks that drivers wanted to operate because comfortable, reliable trucks attracted customers. Soviet truck factories operated under central planning directives that emphasized production targets and weight capacity. There was no market feedback loop, no mechanism for driver preferences to influence design decisions. Moscow, 1946. The war ended in May 1945. The Soviet Union emerged victorious, but devastated. An estimated 27 million Soviet citizens died during the war. Industrial production had collapsed in the western regions. Entire cities lay in ruins. Stalin faced the massive task of reconstruction while simultaneously maintaining military readiness for potential conflict with the United States and its allies. The Red Army needed vehicles for the post-war era, and Soviet industrial planners looked to American trucks as the template. The decision to copy American truck designs was explicit and documented. In 1946, the Soviet Ministry of Automotive Industry authorized reverse engineering of the Studebaker US6 and other American models that had proven themselves during the war. Soviet engineers at the ZIS factory in Moscow, which had produced the ZIS-5 before the war, began detailed analysis of American vehicles. They measured dimensions, tested materials, and documented manufacturing techniques. The goal was not to produce exact replicas. Soviet factories could not replicate American production methods directly. Instead, Soviet engineers aimed to adopt American design principles while adapting them to Soviet industrial capabilities. The result was the ZIS-150, introduced in 1947. This truck featured a layout clearly influenced by American designs, with a six-cylinder engine, a similar cab structure, and a cargo capacity of 4,000 kilograms. The ZIS-150 looked modern compared to pre-war Soviet trucks. It had an enclosed cab, a curved hood, and styling that echoed American automotive design of the late 1940s. Production began at the reorganized ZIS factory, which had been rebuilt after wartime destruction. The factory was renamed ZIL, Zavod imeni Likachova, in honor of Ivan Likachov, who had directed the plant since 1933. By 1950, ZIL was producing approximately 35,000 trucks annually. The ZIS-150 became the standard Soviet military and civilian truck throughout the 1950s. It served in Korea, where Soviet-supplied trucks moved supplies for North Korean and Chinese forces. It appeared in Soviet propaganda films as a symbol of post-war reconstruction. But the ZIS-150 revealed the limits of copying. The truck functioned adequately, but it did not match American standards for reliability or longevity. Soviet drivers reported frequent mechanical failures. Engines developed oil leaks. Transmissions failed prematurely. Electrical systems were unreliable. The problems were not catastrophic, but they were persistent. A truck that should have lasted 200,000 kilometers often required major overhauls at 100,000 kilometers. The core issue was manufacturing quality. Soviet factories operated under production quotas established by Gosplan, the central planning agency. Factory managers were evaluated based on the number of trucks produced, not the quality of those trucks. This created perverse incentives throughout the production chain. Workers rushed to meet quotas, accepting loose tolerances and defective parts to avoid falling behind schedule. Quality control inspectors faced pressure to approve marginal products rather than slow production. The result was trucks that looked like American vehicles but lacked the precision manufacturing that made American trucks reliable. Material quality compounded these problems. American steel mills in the 1940s produced high-grade steel with consistent chemical composition and mechanical properties. Soviet steel production was less consistent. The same grade designation could vary significantly between different mills or even different production runs at the same mill. This variability meant that parts that should have been interchangeable often were not. A replacement crankshaft might fit, but with slightly different tolerances than the original. Detroit, Michigan, 1950s. While Soviet engineers struggled to replicate American truck quality, American manufacturers continued innovating. Studebaker introduced automatic transmissions in civilian trucks. GMC developed improved diesel engines with better fuel efficiency. International Harvester pioneered cab-over-engine designs that increased cargo space. These innovations responded to market demands from commercial trucking companies, construction firms, and agricultural operations. American truck buyers demanded vehicles that minimized operating costs and maximized uptime. Manufacturers competed by improving reliability, reducing fuel consumption, and extending service intervals. The feedback loop between users and manufacturers drove continuous improvement. When fleet operators reported transmission failures, manufacturers redesigned transmissions. When drivers complained about poor visibility, cab designs evolved. The market rewarded companies that listened to customers and penalized those that ignored feedback. This system generated incremental improvements that accumulated into substantial advantages over time. Soviet truck development lacked this feedback mechanism. Drivers had no choice in vehicles. Military units used whatever trucks central planners allocated. Civilian transport organizations operated under state directives. There was no competition, no market pressure to improve designs. Driver complaints traveled through bureaucratic channels that might take years to reach designers, if they reached them at all. The system optimized for meeting production targets, not for serving users. By 1960, the gap between American and Soviet trucks had widened, despite the Soviet Union's attempt to copy American designs. The International Harvester Lodestar, introduced in 1962, featured power steering, air brakes, and diesel engine options with significantly better fuel economy than comparable Soviet trucks. The GMC 5000 series could operate reliably for 300,000 kilometers with routine maintenance. Soviet trucks of the same era typically required major overhauls at 150,000 kilometers. The human cost of this reliability gap was measured in driver fatigue and operational inefficiency. Soviet truck drivers spent more time maintaining vehicles and less time driving. Breakdowns on remote highways meant hours or days of delay. The lack of comfortable cabs and reliable heating systems made long-distance driving physically exhausting. American truckers, by comparison, drove in heated, cushioned cabs with reliable vehicles that required minimal, unexpected maintenance. Naberezhnya Chelny, Tatarstan, 1969. The Soviet government decided to build a massive new truck factory capable of producing 150,000 vehicles annually. The location chosen was Naberezhnya Chelny, a small city on the Kama River in Tatarstan. The project was named the Kama Automobile Plant, or Kamaz. But Soviet planners recognized that domestic expertise was insufficient to build a factory of this scale and sophistication. They turned to the United States. In 1971, the Soviet Union signed contracts with American companies to design and equip the Kamaz factory. The Swindell-Dressler Company of Pittsburgh provided foundry equipment. Gleason Works of Rochester, New York supplied gear-cutting machinery. Holcroft Company designed heat-treating facilities. Ingersoll Milling Machine Company provided specialized machine tools. The list extended to dozens of American firms, each contributing specific industrial capabilities that Soviet factories could not provide. The irony was profound. 26 years after copying American truck designs, the Soviet Union still needed American industrial technology to build modern truck factories. The issue was not knowledge of truck design. Soviet engineers understood truck engineering. The problem was industrial capability. American machine tool manufacturers had spent decades refining production equipment for automotive factories. Their machines could hold tighter tolerances, operate more reliably, and produce parts faster than Soviet-built equivalents. The Kamaz factory opened in 1976. It represented the largest automotive investment in Soviet history. At full capacity, the factory employed over 100,000 workers and produced heavy-duty trucks designed to meet Soviet long-distance freight needs. The Kamaz 5320 became the standard Soviet long-haul truck of the late 1970s and 1980s. It featured a diesel engine, a more comfortable cab than earlier Soviet trucks, and improved reliability compared to previous models. But even with American equipment, Kamaz trucks did not match Western standards. Quality control remained inconsistent. Soviet material science still lagged behind American capabilities. The systemic problems that had plagued Soviet truck production since 1946 persisted. The Kamaz factory could produce large numbers of trucks, but those trucks still required more frequent maintenance and had shorter operational lifespans than American or European competitors. The meaning of failure in Soviet truck development was relative, not absolute. Soviet trucks functioned. They moved freight, transported military equipment, and served agricultural operations across the vast territory of the USSR. Millions of Soviet trucks operated throughout the Cold War era, but they failed to match American standards for reliability, efficiency, and driver satisfaction. They failed to become globally competitive products that other nations chose to purchase when alternatives were available. The fundamental problem was not engineering knowledge. Soviet engineers understood mechanical principles. They could read American truck manuals, measure dimensions, and replicate designs. The problem was the industrial and economic system producing those trucks. Central planning eliminated market feedback. Production quotas prioritized quantity over quality. Material inconsistency undermined manufacturing precision. Driver comfort was never a design priority because drivers had no alternative choices. By 1991, when the Soviet Union collapsed, its truck industry remained decades behind Western standards. Russian automotive factories in the post-Soviet era struggled to compete with imported trucks from Europe, Japan, and eventually China. The legacy of copying American designs, without copying the system that made those designs successful, continued to haunt Russian truck manufacturing into the 21st century. The lesson was clear and brutal. The USSR copied American trucks as products, but could not copy the system that made them successful. Technology transfer requires more than blueprints and dimensions. It requires market mechanisms that reward quality, manufacturing systems that maintain precision, and feedback loops that connect users to designers. The Soviet command economy could mobilize resources, build factories, and produce impressive quantities of vehicles, but it could not replicate the invisible infrastructure of competition, accountability, and continuous improvement that made American trucks reliable. The Studebaker US6 that rolled through Stalingrad in 1942 represented more than a vehicle. It embodied an entire industrial ecosystem that the Soviet Union spent 4 decades trying to replicate and ultimately could not match. The trucks that saved the USSR during World War II became the standard the Soviet Union could never achieve.